I would like to introduce Takaya Nakagawa, who will be presenting fundamental techniques of maintaining optical connections in the multi-core connector. Takaya is a sales engineer at NTT Advanced Technology based in Japan. He has been with the corporation more than 20 years and is responsible for network design, construction, and maintenance. In recent years, he has deployed RPA-based business automation and optical network solutions and whitebox solutions. It's a pleasure to have him with us today. Welcome, Takaya. The stage is yours.
Thank you. Let's push. Hello, I'm Takaya Nakagawa. I'm based in Japan, and I would like to talk about a little bit about what I do. My team develops and sells manufacturing equipment and tools for optical connectors, connector cleaners, and other optical communication-related products. And let's see. Let's start by briefly talk about trends in the Ethernet standard. The graph shows the Ethernet standard that has been completed up to 800G. High-speed communication between the GPU server is also an essential requirement for the generative AI, which we hear a lot these days. As such, high-speed Ethernet standards are being proposed, but optical connectors are always used for the transceiver's interface of each standard, making optical connector connections unavoidable. Now, let me talk about introduction of the optical connectors. Optical connectors are components used to connect and disconnect optical fibers. It must be able to connect an optical fiber accurately at a low cost and easily be used so that anyone can use them. There's a tiny light path in the center of the fiber that is about the thickness of the human hair, and it is necessary to align this precisely. First, let's talk about the main types of the optical connectors. I believe that most of the optical connectors used recently are the SC and LC connectors. I suspect that many of you have here today used these two types. What these two connectors have in common is that they all contain only a single fiber apiece. The MPO connector shown on the right of the table contains multiple fibers. The diagram shows comparing the connector size, and the difference in the size is clear when simply comparing the MPO connector with the 12 fibers side by side with 12 LC connectors. However, disadvantage is that if even one of the fiber fails, the other fibers will be affected when replacing it. As you can see, the MPO connector is a unique device and significantly changed the conventional concept of optical connectors. And recently, the use of MPO connectors has been rapidly increasing. The MPO connector has some difficulties, and the structure is a little unique when comparing with the existing connectors such as SC or LC. Things like polarity and connector pins are new things. I'll try to explain some of the questions you may have, especially in the first time to use the MPO. The slide compares the structure of the single fiber connectors and large fiber connections. In the single fiber connectors, the ferrule are aligned with the split sleeve. On the other hand, large fiber connectors align the ferrule using a guide pin and guide hole. The main difference here from the single fiber connector is that presence of guide pin and guide hole. Both connectors use the same kind of structure using the spring to press the ferrule together. The slide compares the fiber end face and its shape. When comparing, the photo clearly shows that the ferrule are different. By the way, the various size lumps around the fibers in the multiple connectors are the glass filler mixed into the plastic to increase the strength. The 3D image of each measured end face also clearly shows the difference in the shape. The single core connectors, ferrule and core has matched surface. On the other hand, you can see that the MPO's fiber pops up from the ferrule. The 3D image of the bottom right is little emphasized so that you can see it easier to see. The MPO connectors are available with different fiber counts. The MPO connectors are primarily available with 12 or 24 cores, but some Ethernet standards also specify 16 and 32 cores as well. The diameters of the guide pin and the guide holes are different between 24 connectors and 16 and 32 connectors. The position of the key is also different. For this reason, 12 and 16 core connectors are physically able to be connected. But however, 12 and 24 core connectors have the same structure, but just the difference is the numbers. The same is true for the 16 and 32 core connectors. It is possible to physically connect, but the communication will not be established, so care must be taken. While it is possible to physically contact 12 and 24 cores and 16 and 32 cores, but it is difficult to tell by just looking at it. The fiber types and number of the cores are usually printed on the cable, so please check there. It is possible to visually check the MTFO itself, but in that case, please make sure that nothing is connected on the other end. It is extremely dangerous to look directly at a ferrule when it's emitting a light. Next one is a polarity. When using an MPO cable, you may find that sometimes some reason this doesn't link up. This may be due to the incorrect polarity connections. MPO connector has polarity, which was not present in the previous single fiber connectors. When wiring MPO cable, it is necessary to connect the correct polarity. The polarity of the MPO connectors is slightly similar to metal cable. Type A is a straight through. The MPO cable that has a key up connectors on the one end and a key down connector on the other end, so that the port 1 goes to the port 1 on the opposite side. The type B is called reverse or cross. Both MPO will be the key up, and port 1 goes to port 12, so it will be the cross connections. And type C is called cross pair or flip pair. A key up connector is used on the one end and the key down connector is used on the other end. But the flipping happens inside the cable. With each pair of the fiber flipped so that the fiber in the position 1 goes to the position 2. At the other end, and the fiber position 2 goes to position 1. As shown in the slide, there are mainly 3 types of cable, but type A and type B is most commonly used, and type C is only used on special cases. If the polarity is incorrect, the link will not come up, So MPO polarity is very important. Now, let me explain the measurement. As explained, MPO connectors contain multiple fibers, such as 12 or 24 fibers. So the dedicated measurement instrument is required. Normally, an optical power meter that can handle the MPO is recommended. When using the device that can directly connect the MPO is operatable the same way as conventional power meters. The downside is that MPO-compatible power meters are expensive. On the other hand, if you use the fan-out or breakout cable, it can be measured with the conventional single-fiber meters. A breakout cable, as shown in the bottom of the slide, is a cable that has an MPO connector on the one end and a single fiber connector such as LC on the other. If you connect a power meter for the single fiber connectors to each of these branches, you can measure the optical power level. However, since you have to connect and disconnect each fiber one by one to measure it, this is naturally the time consuming. And if you have a large volume to measure, it might be a better idea to get a dedicated device. The next one is the next generation optical connectors. So far, I've explained the connections, principles, and characteristics of optical connectors focusing on MPO. Next, I'd like to talk about the next generation optical connectors. The optical connectors may be in the transitional period. The LC connector was introduced in 1996, and it has been almost 30 years since then. MPO connectors has been recently began to gain the popularity, but they were also developed at the same time as LC connectors. While no new connectors has become mainstream in the past, there has recently been active development of optical connection known as VSFF, very small form factor, which allows higher density connections. We don't know if these will be mainstream in the future or not. So here's a summary of the multiple reflection which I've talked last time. We confirmed that the multiple reflection caused by the interference in the transmitted light wave, resulting in degradation. We also confirmed that as the optical power level decreased, the impact of the multiple reflection on the transmitted light increased. For this reason, the optical fiber transmission path with many optical connectors connection point requires a caution. And if you wanted to know more about the multiple reflections, please check my last presentation on the 94. The image shows the connection part of an LC connector seen from the side. The end face of the connector is machined to be slightly rounded. The optical fiber are connected to each other with a force that is just enough to slightly crush the tip of it. Since this is a physical contact, it is easy to imagine what would happen if the dirt exists. As you can imagine, a dirt will deteriorate its optical characteristics. We think that lots of problems in the optical networks are caused by the contamination of optical connectors. We are often asked how much of the impact do they actually have, and I will explain the result of the test to see what happens when there is a dirt in the end face of the optical connector. On the left slide, these are the reference value for the clean interface are connected. The middle shows the data when hand oil was applied. Hand oil were applied to the optical connector interface by touching them with a finger. As you can see, there is a slight decrease in the optical characteristic. Also, when the connector 2 is clean before connections, but the dirt will be transferred after the connections. So make sure both ends are clean before connecting it. Next on the light is the data when dust was applied. The dust was applied by touching the connector with the closing. Both the insertion loss and the return loss were very poor, and you can see that there has been a greater effect on the optical characteristic compared with the hand oil. And a few points for the MPO. If there is a dirt around the guide pin, it can cause a problem such as insufficient pressure or resulting the gaps in and poor optical characteristics. There's also the issue of the guide pin hole wearing down. If the connector is not inserted or removed straightly, it can become worn down and as shown in the photos. In the most cases, once it's connected, it will not be removed often, but if it is inserted and removed frequently, please be sure to insert and remove it carefully. As you can see, there are several types of optical connector cleaners. There are cleaners that are specialized for the connector side or the adapter side. And recently, there is also a pen-type cleaner that are compatible with both. There are also alcohol and compressed air cleaners, but generally it is better to use a dedicated cleaner as it requires less skill to clean. I will explain how to actually use them in the next slide. The first one is a real-type cleaner, specialized for cleaning the connector side. To use it, first open the shutter, and then second, place the connector interface vertically against the cleaning cloth. The third, slide it while still pressing the perpendicularly. The important thing here is that to place the optical connector interface vertically against the cleaning cloth with enough force to slightly make a dent in the cleaning cloth while sliding it. If you apply too little pressure, the connector will not be cleaned. So be sure to apply firm pressure while cleaning it. And please note that for the MPO connectors, sometimes dedicated type of the cleaners are needed for the ones with a pin or without pins. The next one is a stick type cleaner, which is specialized in cleaning the adapter side. And to use it, it is simple. First, insert straight into the adapter. Second, press against the ferrule. Third, rotate 4 or 5 times in the same direction. Key is to move it in the same direction. The important thing is to apply the pressure, just like the real type. The disadvantage is that this type of cleaning requires some skills, and also they are basically disposable after a single use. So if you reuse the stick, there is a risk that the dirt that was wiped away and trapped will be pushed back into the new one and to the connector interface. So just use it only once, okay? The last one is the pen type cleaner. This is a convenient cleaner that can be used on both plug and adapter side. To use it on the plug side, attach attach the attachment cap and push it in. To use it on the adapter side, insert into the adapter without attaching any cap and push it in. The pen type cleaner is very popular these days because it can be used both sides and requires no skills. This cleaner is also ideal for cleaning the optical transceivers, and these types of cleaners usually available in the MPOs as well. The only weakness is that cleaning range. Only the center of the fiber on the connector its interface can be cleaned. But however, the pen type cleaner's cleaning range is usually enough, unless if it's like so dirty. The thing I wanted to say is it's very important to clean the cable and also the adapter before you use it, even if it's new. It may be like, if you have the like microscope or some kind of like measurement tools, it's probably the best to use it. But it takes some time and effort to check the like cable if it's clean or not with the microscope. So it's probably best easier to just clean it and then use it. And that's what I want to say. Thank you.